Hello, this is Miss Moore, and we are going to continue our discussion of the gas law. Today we're going to talk about the combined gas law. So, essential question: how do pressure, volume, and temperature of a gas interact to affect the behavior of a gas? All right, the combined gas law. The combined gas law uses all three variables, pressure, volume, and temperature, in predicting the behavior of a gas under various conditions. So today we're going to continue using our formula P1V1 over T1 equals P2V2 over D2. This is the last law, gas law, that uses this equation. So P1V1 over T1 equals P2V2 over T2 is used for Charles' law, Gay-Lussac's law, Boyle's law, and now the combined gas law. All right, today's lecture is going to be really easy. What we're going to do is two practice problems. If you think you can do this without my help, why don't you hit pause and try to do it, and then hit play and see how you did. All right, so we're going to be still using the same formula, P1V1 over T1 equals P2V2 over T2. And let's read through the problem and list out our variables. Let's go ahead and try highlighting the ones in yellow. We'll start with that. So we have a weather balloon containing helium with a volume of 410 liters. It rises in the atmosphere and is cooled from 27 degrees Celsius to negative 27 degrees Celsius. So I would say that's our original temperature, right? The pressure is reduced from 110 kPa to 25 kPa. What is the volume of the gas at the lower temperature and pressure? Okay, so our V1 is going to be that one, and now our 2's are going to be the negative 27 degrees Celsius, the 25 kPa, and the, what is the volume? All right, let's go ahead and fill this in. 410 is our V1, 27 degrees Celsius is our T1, and 110 kPa is our P1. All right, when we go to our 2's, we have 25 kPa as our P1. Our volume is X, and our T2, sorry, these are 2's. Our T2 is negative 27 degrees Celsius. Okay. So the first thing we have to do before we even plug this stuff in is figure out our temperatures in Kelvin, which, remember, you take your Celsius temperature and add 273 to get Kelvin. And I got 300 K for T1 and 246 K for T2. All right, so now let's block this stuff off. Now let's go ahead and plug this into our P1V1 over T1 equals P2V2 over T2. So we're going to have P1 times V1, over T1 equals P2 times V2 divided by T2. All right, and from here, I'm going to go ahead and make us a little space here. I'm going to get rid of that. The next thing we can do is cross multiply, giving us 110, write that a little neater, 110 kPa times 410 liters times 246 K equals 300 K times 25 kPa times x. All right, so let's go ahead and do our multiplication there. And when I multiplied the left side, I ended up with 1109.4.6 kPa liters K. And for the right side, I got 7,500 K. I guess I need to put this down below. I got 7,500 K kPa x. All right, so now to get the x by itself, we're going to go ahead and divide by everybody next door to the x, which is 7,500 K kPa. So 7,500 K kPa. So our K's cross out and our kPa's cross out. And that gives us 1479.28 liters. So now we need to go back and look at sig figs. We have 2 and 2 and 3 and 3. So it'll be 2. So our final answer will be 1,500 liters. Not much different than doing Charles, Boyle's, or Gay-Lussac. The only difference is just a few more numbers to poke in. All right, pressure unit conversions. You should have this equality, actually probably a bit longer, on your unit conversion table. So this is a big old equality here where 1 atm equals 760 torr equals 760 millimeters mercury equals 101 kPa. All right, and because these are constants, or we didn't measure them, these are not used to determine sig figs. Okay? They are not used to determine sig figs. Okay, so what we're going to learn how to do today is if we get a problem where we have one unit in millimeters mercuries, let's say, and the other pressure unit in kPa, we need to convert between those units, get them the same. And to do that, you use the 3-step factor-lable method and one of the equalities from above to convert between pressure units. All right, so now we're going to try a problem. All right, so let's read through this thing here. We have an elastic container inflated to a volume of 18 liters at a pressure of 983 torr. Those sound like they go together because we've got a certain number of liters at a certain pressure. The container then expands to a new volume at a pressure of 700 kPa. What is the new volume? All right, so we're going to be using the equation P1 V1 over T1 equals P2 V2 over T2. So let's now list out our variables. So our ones are going to be 18 liters and 983 torr. Whoops, torr. And our twos are X and 700 kPa. All right, so before we can start the problem, hopefully you guys notice that we have torr and kPa. Those do not match. We need to take those pressure units and they need to match so we can cross them out. It doesn't actually matter which you convert to the other, but what I normally do is pick the first unit. The first pressure unit is the unit I'm going to keep. I'm going to keep torr. The one I need to change is kPa. So when I go to write a math problem, I know I have 700 kPa. I want to know what that is in torr. Okay, and from here you do your normal unit conversion setup. So we'll start with our known, 700 kPa over 1. Now we need to find an equality that has both kPa and torr in it. And so we have here 760 torr equals 101 kPa. So 101 kPa equals 760 torr. Try that again, 760 torr. All right, so who's going to go on the bottom? We'll put 101 kPa on the bottom so they can cancel out, and on the top would go 760 torr. kPa cross out, and now multiply across the top, and that gives us 532,000 torr over 101. And when we divide, I got 5267.3 something 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 torr. Okay, so let's look at our sig figs. We have 4 sig figs, so we'll have 5267. So now, instead of using 700 kPa, we'll use 5,267 torr. Now that we have our pressure units the same, they're now both in torr, we can plug our numbers into our equation, and this is going to be a Boyle's law because we just have pressure and volume. So we'll have 983 torr, which is our P1, times our V1, which is 18 liters, equals our P2 times V2. All right, so when we multiply the ones, I came up with a 17694 torr liters equals 5267 torr x. Okay, we need to get the x by itself. We'll do that by dividing both sides by the 5267 torr. Torr crosses out, and that gives us 3.3594 something something liters. All right, so now we need to look at our sig figs. So we have 3 and 3, and here we're going to use the top number here, and that is 4. So we're going to end up with 3 sig figs. So our final answer is 3.36 liters. Not too bad.